Welcome to After the Breach podcasts. We're your hosts, Jeff and Sara, and back with us today we have Monika Wieland Shields from Orca Behavior Institute and Michael Weiss from Center for Whale Research. We had a lot of fun recording our Demystifying Killer Whales episode, but we're here to talk a little bit more about some other things that have been going on.
And I think we're all a little bit more awake than we were then.
A little bit more coherent.
Yes.
Yeah, it's not August.
Maybe. We'll see.
We'll
see how coherent
it might
this
default.
is.
Yeah, we'll see.
But it's the only thing, it's not August. We know that.
Yeah. But thanks for joining us.
Always
Both
a pleasure
of you.
to be here.
Yeah. I feel like I've been on this show now like 4 times and I've been in 3 different recording spaces. So that's really cool.
Soon to be another.
Yeah.
When we do our next one at the new office.
We might just keep moving this around. We might get a van and start recording in the van from different locations.
Oh, like moving during the recording.
I like
Just
that.
Keep the van moving as you record.
I like that, with a speaker on top of the van so everybody can hear what we're saying in real time.
All right, so we've already devolved.
We've lost the plot.
It's
been
we've
30
lost
seconds.
it.
What is the plot? What are we here to talk about?
This is episode 37 of After the Breach podcast. What are we talking about?
So I think we wanted to talk about some of the awesome research you guys are doing. We just had the first field season down in Puget Sound. And then we wanted to also talk about the differences between bigs and southern residents and the calf survivability. We had L90 with a new calf this year that did not survive. And we wanted to kind of talk about the highlights between both populations and things that come into play with that.
Well, let's maybe start there.
We'll start with
work our way up.
Yeah.
I don't know, Michael, do you want to summarize what happened with L90 this fall?
Yeah. So all 3 pods of southern residents had come into inland waters and made their way up into the Strait of Georgia. We were able to have an encounter with them, and I believe that was on September 13th. And actually, we saw L90 on the 13th, no calf. Then she made her way back down, and on the 15th, folks, I believe, sent photos to the whale sightings page, is where the first photo showed up of L90 with a very, very small calf. Initially, there were reports that there were maybe other animals out there with her, but when we got out on the water, it was really just L90 and the calf. And when we got on scene with them, the only thing that was really weird was that they were alone, which honestly isn't that weird. Talking to Dave Ellifrit, my colleague at the center, there are a few, examples of new moms, especially first-time moms, kind of looking for some alone time after having their calf. Mom looked okay. Photogrammetry from SR3 showed her in normal body condition. So, very much within the range, what you'd expect for a female of her age at that time of year. And the calf, it's really hard to say what its body condition was because it's by far the youngest, smallest calf that SR3's ever measured. And it's about as, new of a calf as you can see. It was probably less than 48 hours old, but it was very small, very wrinkly, but it was nursing, it was moving, kind of how you'd expect in mom's slipstream, holding infant position. They then kind of disappeared while they were in inland waters. They made it pretty clear to us and every other research boat out there that they wanted to be nowhere near any research boats. We could not get a photo ID pass on them. The only way we got an eye patch on the calf was by putting the drone up. And then they disappeared. Nobody was quite sure where they went, if they were still up north or if they were out west. But then our colleague, Mark Mallison, who is a whale watch captain, but also does contract work for the center, was out there, and he, way out west, found what he initially thought was a new calf swimming with L83. A new calf in really quite poor body condition that L83 was kind of pushing around a bit. And Mark wasn't sure if the calf was still alive at the end of the encounter, but he was pretty sure he saw it breathing. He sent photos of that calf to myself and Dave. And by comparing that with eye patches and also looking at the dorsal fin shape and the saddle patch, we were able to figure out that was L128, was L90's new calf. We're not sure why it was with L83. Whales get babysat even when they're very young. L83 would be a more experienced mom to potentially help out. And after that sighting, the calf was never sighted again. So that was the last time we have sightings of that calf. So we now consider that calf to be deceased. Unfortunately, like it's really sad, but it's also just not that surprising. Even though nothing was kind of visibly, obviously wrong with the calf or mom when we first saw them, like the fact of it is, even calves we see that we eventually do document alive are really likely to die in that first year. And that's not counting all the calves that we never see. This 2/3 pregnancy failure rate that gets quoted from the hormone data. The hormone data can't distinguish between late-term spontaneous abortions and calves that are born but die very, very young, right? It's just times we know there was a late-stage pregnancy, but we never saw a calf. And it's very rare that we see a calf this young. So it's not all that surprising that the odds were against a 128 when it was a calf we detected so young. We were always hopeful, like, oh, look, it's nursing, it's moving right, mom looks okay. Maybe this calf has a chance, but statistically, the odds are, at least in southern residents, always kind of against them at that age.
And we talk about that a lot at the population level, but L90 herself was kind of a unique situation as well, because she was the oldest documented first-time mom in southern residents. Yeah, and we're not sure if maybe she's given birth before and the same thing happened and we never saw it. We definitely know she's been pregnant before. She's one of those whales who like gets a particular kind of movement when she's pregnant. She gets stiff-backed, and Dave kind of thinks she's so small that something about the pregnancy is making it harder for her to move. Mm-hmm. But yeah, in terms of documented live calves, it's the oldest first-time mother we have by like a considerable margin, like a several-year outlier. The next oldest is L54, and there's, I think, like 5 or 6 year difference between those two. And just for our listeners, L90 was born in 1993, so she would have been 31. Yep.
So it was a sad year for folks because at the beginning of the year, we lost J60, the previous documented calf, and then L128. And it led a lot of people to wonder what's going on. Why are there 2 births, 2 deaths? But some of it is just sort of small number statistics, I think, where we know there's a high mortality rate in calves. And you're going to have some of these patterns where some survive, some die, maybe consecutively. And that doesn't necessarily mean something greater in the grand scheme of things. For instance, the previous 9 calves documented born to the southern residents are all still alive.
Yes. And I will also say J60 also falls into that category of a calf we detected unusually early.
Like within 48 hours of birth.
Yeah. So yeah, I would agree that I'm not saying there's nothing going on, but 2 deaths of very young calves in the southern residents is not enough to really draw a conclusion about a trend or a thing happening in time. It's not good, but it's also there's every potential that slight change in the timing of those pregnancies, and we never would have even known either of those calves were born.
Absolutely.
Are these numbers that we're looking at with southern residents, what is this a normal thing with wild killer whales? Like, how much do we know about other populations, northern residents, bigs, any other populations, to compare what's happening with the failed pregnancies with southern residents and the high number of that?
Yeah, it's interesting. I don't think there's been good published estimates on like pregnancy failure rates in northern residents or bigs. But we do know that they both have higher reproductive rates. I mean, that when you look at the southern residents versus other killer whale populations, there is a slight difference in survival. Like southern residents don't survive as well. But the big thing that's impacting the population dynamics is much lower observed reproductive rates. And that includes both successful pregnancies and, keeping a calf alive long enough to be detected.
Sure.
So sort of the old fact that everyone has always thrown out is like a 50% mortality rate in the first year of life for killer whales is sort of what I've heard. I don't know how much data and from how many different species that really is. We certainly see a much higher survival rate of documented calves in Biggs killer whales with that. And even really in the last 10 years in southern resident killer whales of documented calves. So, I think these are our two most well-studied populations. And it's tough to draw conclusions from other populations that aren't observed to this degree.
Yeah. And I think that 50% doesn't come from a number of like, we see we observe X number of calves and then 50% of those survive. I'm pretty sure that number comes from that Alessiak paper in 1990, which is not just using number of observed births and deaths. It's doing some population matrix projection, kind of saying, okay, we think females produce this often. Here's the age composition of the population. The only way you get there is if there is X mortality early in life, making some assumptions. And it's probably not that far off if you take into account calves we never observe, but certainly in terms of the calves we survive long enough to get a number, the observed survival rate is higher than 50%.
Yeah, it certainly seems to me, and I don't have the data, but just anecdotally, since I've been here, it certainly feels like the survival rate with Bigg's killer whale calves is way higher than 50%.
This is why you invited me to have the numbers, right?
Of course.
Not just that reason.
So,
but you always have the numbers.
I do. Over the last 10 years in the Bigg's killer whale population, of the calves that received numbers, 88.8% of them are still alive today that we know of. So we're talking, and these numbers just blow my mind. We're talking 143 births in the last 10 years.
Sorry, and that's alive to not surviving their first year. That's alive to this day.
Correct.
Wow.
So
143 births in the last 10 years.
In the intercoastal portion of the Bigg's killer whale population in the last 10 years. So again, almost twice the number of southern resident killer whales. 16 of those whales are no longer living. So yeah, close to 90% of them are still alive.
That's amazing.
That's wild. I was doing some modeling today with southern resident data, fitting some survival models. And these are Bayesian models. So there's something called shrinkage involved, which means, it takes more data to pull things away from the mean. But even in this model, like the estimated year one survival for calves that live long enough to get a number is still like 70%. That's just year one in southern residents. So like, what was that time frame you were just quoting?
10 years.
Yeah. They're like, if 70% of them are gone in year one, you can imagine how much lower it is over 10 years. So the idea that there's like almost 90% of those calves are still around is wild to me, especially considering the fact that I would think in general, it takes us longer to find. Well, no, probably not in the last 10 years. I think in general, it's probably historically taken us longer to find Bigg's calves, but, in the last 10 years, we probably see Bigg's calves quicker, at least of the more common matrilines, quicker than we do residents.
So your survival estimates from the statistical models are going to be a lot more accurate, but just doing a similar comparison to southern residents in the last 10 years, 19 births, five of those no longer with us. So that's about a 74% survival rate over that same time period.
That sounds about right. I mean, so my models are including dead neonates that are never given a number, but we were able to assign maternity. So it's going to be a little bit lower, but that sounds in line. Yeah. With what the models are saying.
So are you thinking this all comes down to food and nutrition? And that's where you're seeing the difference and such high numbers of survival in Bigg's killer whale calves?
Really, what's striking to me is the survival numbers aren't as different as I expected, honestly. Like, we're looking at 74% for southern residents, 89% for Bigg's. But like Michael said, the difference is in the reproductive rate. So if you look at the number of reproductive females in the population, it's something like 0.6 calves per female for the southern residents, and 3 times that, 1.7 calves per female in the Bigg's over that same time period.
And and the survival rates aren't that different. But I think if you invert those and instead say 84% survive or 89 versus 74, invert that and say 11% mortality versus 26% mortality. It actually, it's over twice the mortality rate in southern residents. But yeah, I mean, where the huge difference is coming is absolutely in the fact that the Bigg's are just producing more calves, per female than the southern residents are.
And we've seen that recently, not just with over 10 years, 1.7 on average, but some of these females are giving birth literally every 2 years. Like we've seen some where it's like a 2-year interval between calves, which is not something we're seeing.
And I'm sure there are some other factors that come into play with, potentially genetics and disease and stuff like that. But I think you're absolutely right that prey is at the root of this, where if you're going to be pregnant and nursing at the same time, you're going to have to be taking in a lot of calories. And for some of these moms, that's also provisioning young juveniles on top of that. So,
and maybe the bigs just have a higher sex drive.
Oh my God.
Is that what you've been smiling about all this time, waiting to make that comment?
I can say behaviorally, absolutely not. I don't think there's many animals with a higher sex drive than a resident killer whale, just like based on behavioral budget. They spend a lot of time doing that. It's just, and I think they get pregnant. It would be really interesting. And I don't think we have the fecal samples to look at it. It'd be really interesting to see if actually there might not be that much of a difference in pregnancy rates. I wouldn't doubt that the southern residents are getting pregnant a bunch. I mean, we know they're getting pregnant a bunch. I wonder how much of that is difference is in pregnancy failure or very, very early mortality in the calves, like within the first few days.
And some of this in terms of pregnancy detection is coming from the photogrammetry work on southern residents that's targeted towards looking at that sort of thing. But I find it really interesting that it's much harder to determine pregnancy in the big killer whales through that method as well, where just because of their body shape and how robust they are, it can be more difficult to detect pregnancy. So maybe that's what you're suggesting, that you would need the fecal samples to really confirm.
Yeah,
Right.
I think so because, we don't do any like actual photogrammetry, but if I'm flying over a group and I see a really fat female, I'll kind of make a note and let people know, I think this whale's pregnant. It's hard with bigs. They're all so fat, and you see a really fat female, and especially if I've been looking at residents for the last few months, my brain in me goes, oh my God, everyone here is pregnant. It's like, they're just well fed.
It does make me kind of wonder, going back to, prey as a thing and pregnancy rates, like how much toll does it take, a pregnancy take, even one lost in like the first 6 months of a pregnancy on that female who maybe is going to get pregnant again and not have as good of a chance the next time of keeping that pregnancy if she's already has a decreased condition because of a previous failed pregnancy.
It's weird because there's two balancing things there. There's the energy you're putting into raising a calf or gestating a calf and lactating, but there's like on the flip side, there's the offloading of toxicants, of contaminants. Like this, it's really grim. Like the silver linings we are forced to pull out makes it like really grim. But when a female like L90 has her first calf and isn't able to keep it, there is like at least the little thing of, well, maybe she'll have better luck next time. Like maybe if she can have another calf soon, she's going to have a lower toxin load when she's gestating and nursing that calf, and maybe there'll be better luck.
So folks who maybe aren't familiar with this, killer whales being at the top of the food chain carry pretty high toxin loads. And the females offload those toxins both when they're lactating, but also in utero when they're pregnant. So we see females with more calves have lower toxin loads. And typically, when they're first giving birth, they have had 15 or so years of toxic accumulation. And so that can contribute to potentially a higher mortality rate of firstborn calves getting that kind of influx of toxins at that key phase of development.
Which is another reason why I find the big killer whales, the calf survival rate so amazing, is because their toxic load, because they're eating higher up on the food chain, is so much greater that you would almost think that they would have a lower calf survival rate because of the offloading of a much more higher concentration of toxins, but we're not seeing that come into play.
Well, and this is something that needs, I think, greater study. So there's good evidence from animals in captivity and from studies that animals with more blubber, that are in better physical condition, in the same environments, have lower blood serum concentration of a lot of these toxins, which are lipophilic, which stick to fats. So we know that if you're in good condition, you have lower circulating PCBs and other POPs. What I don't think has been studied very well is how maternal condition affects offloading during gestation and during lactation. So does a mother in better condition offload less toxins onto the calf? Or is it just the calf's getting the same amount, but the calf is also so fat that it's all, getting locked up in the blubber? It's really hard to study. Like the conditions you need to study that are, you need good samples of a bunch of females that tells you what is their body condition during and immediately after pregnancy. And then you also need samples from that calf to say, are their blubber and serum concentrations of PCBs and other contaminants. And it's just hard data to get. My suspicion would be if you have lower circulating PCB, you're probably transferring less to your calf, but that's, to my knowledge, never been demonstrated in cetaceans.
So even if we don't have the data of what the exact mechanism is, I do think it's very clear that if you and your calf are both getting enough to eat, that toxin issue is mitigated.
Yeah. Yeah. I mean, just by the sheer fact of bigs having a higher reproductive rate than residents, one way or another, the amount of food they're getting is mitigating it for sure.
I think the common thread of what we talk about so often, and not just the four of us, but just on all of these episodes, the common thread is it all comes back to food.
Yeah. Yeah. I think it's tough on the population kind of viability side and the conservation side, because it is the big lever we need to crank is prey abundance for residents, but it's a lever that is hard to pull in the first place because of the different stakeholders, but also like it takes time to pull that lever. And it's really frustrating because I think we bang our heads against the wall, and I'll speak for myself. I want something faster and easier and simpler, but there just isn't anything.
Like going after whale watching.
Sure. Or, I don't know, like hit them with a boost of hormones or something to make them have more kids. I don't want to do that, but I'm saying, like, as an example, like it would be great if you had a literal, silver bullet that's like, oh, you just do that and you'll have more kids, or we just give you this environment and you'll have more kids, or we just, but it really, every bit of analysis you do and every way you draw out the different causal pathways between environmental things and none of it works until they have more food. Mm-hmm. And it's really obvious and really frustrating.
But maybe with what we're seeing in the early returns after the removal of the fish farms with an increase in salmon, maybe that lever isn't as hard to pull, and maybe it will be faster than.
There are levers that have been pulled for sure. Yeah. And I think it will still take several years to really see all the results of that. And I think that also explains why two calves dying or two calves living or that sort of thing over the course of a year isn't enough to draw some of these broader conclusions about what's going on at a population level or an environmental level. Michael, I know you and I both get the question whenever there's a birth or a death in the southern population.
What does it mean?
What does it mean? And we have to, it's hard to explain all the nuance behind this, but one up or one down doesn't doom them and doesn't solve the problem.
Yeah, it's frustrating because on one hand, losing one animal is like a greater than 1% change in the population because it's so small. And on the other hand, losing one doesn't mean suddenly everything environmentally has fallen apart. Like one of the big problems for a population of this size is that they're at the whims of what we call demographic stochasticity, which means sometimes things happen that you cannot account for with your variables and your environmental measures and everything you know and can measure about the whales. Sometimes things still just happen. And on one hand, that can be devastating. Like demographic stochasticity can absolutely screw a population. But also, to your point, Monika, it's like, it also doesn't necessarily mean anything measurable or quantifiable has changed for them in their environment. Things happen.
And the reality is that some calves will die. The more big calves survive, but some don't make it. And that's how nature works.
Yep.
And so a single event doesn't explain the greater trend.
Yeah. And I mean, we're still, the next census we do will be the 50th census we've done of the southern residents. And even with all that data, it is still like damn near impossible for me to fit a model that like finds a really good, strong correlate of reproductive success in the southern residents. Like there's a lot of trends we see. There's a few things that are quite strong, but even with all that data in this population, it's still hard to actually piece out these patterns and figure out what's causing these calves to die young. Like forget trying to figure out what causes a first year calf to die, because you're dealing with such a small sample size in terms of, the kinds of models we're fitting. When you look at, okay, just calves we've observed to be born within the study period, what predicts them dying or living in that first year? It's a tiny sample size to do anything with. And the only way to get a bigger sample size is to do the study for longer and have more calves. So right now, like people ask like, yeah, what makes you think a calf's going to do well, or what makes you think a calf's going to do poorly? And it's like, no clue.
So
no clue.
I think a lot of people maybe don't realize like the types of numbers that go into some of these statistics and these statistical models, where you need a lot of data to have very accurate predictions or very accurate results. And 50 years of data sounds like a lot, but if you're talking about the actual number of individual whales that's been born over that 50 years, statistically, it's a very small number compared to what other systems might have in terms of data quantity to input into some of these models.
Yeah. So let's put it this way. Let's say we were trying to tell whether or not a coin was perfectly fair, like a coin flip was perfectly 50-50 fair. I don't have the numbers in front of me right now, but I think across the whole study since the early 70s, I don't know, maybe like 100 animals born. It would take more than that for me to say with any solid certainty that a coin is fair. You could absolutely on a fair coin after 100 flips get 66 heads and 44 tails, and that would not tell you with any huge certainty that the coin was not fair. Now forget trying to just say, what is the overall probability? Now try to ask, what is it about the way your thumb's positioned that determines whether or not you get a heads or a tails? You can start pulling out some trends, and a really strong effect, if the effect is really, really strong, that can show up. But a lot of the effects in ecology are just not that strong. We're not dealing with, these big things where it's like, if this variable is true, it's definitely going to be heads. And if this variable is false, it's definitely going to be tails. We're dealing with like, if this variable is increased by 2 times, we're going to increase the chance of heads by like 0.1% or something, right? Like that. It's ecology effect sizes are dumb usually and hard to piece apart with the kinds of data sets we have.
Should be the title of this episode.
Are you, I'm curious, is there a difference, or is it consistent among J's, K's, and L's with the pregnancy rate and the calf mortality rate? Are those fairly consistent among the 3 pods, or are there any standout differences?
Well, the birth rates certainly aren't the same.
No. K-pod just does not have kids these days. There's some differences in the timing of reproduction as well. When we look at that, K-pod has a lot more early calves across the whole study. When they do have calves, they tend to have them earlier, and then they fall off quick.
Earlier in age?
Yeah.
The females at younger ages?
Yeah, they tend to have calves a little bit earlier. It's a small, it's a subtle difference, but it's there. Yeah, and L-pod has at least historically had lower survival overall than the other 2 pods. That might have to do with like density dependence. You're in a bigger group, maybe there's less food to go around. And it's, again, we're talking about small differences, but there's some evidence that L pod has lower survival rates than the other 2 pods. I still have hope for K pod. I think there's some females coming up who I think are gonna, I think can do it. I have high hopes for K43. She's a big whale. I have high hopes. And she's hanging out a lot with K45, which I think is a good sign. I think a lot of the females start hanging out with young whales when they start getting ready to have their own.
But then you have whales like J40.
Yeah.
Whoa.
She'll get.
I'm not going for you. I'm just saying
she'll get there.
She's been very calf oriented for a while and has yet to have her first documented birth.
I think she'll get there. I mean, she she probably kidnapped J60 for a little bit of time. I mean, so the first female who J60 was observed swimming with was J40. But J40 was definitely not pregnant in late 2023. So definitely not hers. I think she might be a little too baby crazy right now and is maybe having some trouble carrying one to, to term. But I think one good salmon year, I think she'll get there.
That could be now.
Well, speaking of K43 being with K45 recently, we just finished up our first field season down in Puget Sound, or your guys' first field season that tagged along.
You're part of it.
You were there the whole time.
And it just reminded me of that our last day encounter with that group with K43 and K27, K45, J42, J46.
Yes.
Am I remembering correctly? But do you guys want to talk about that study? Because it's really fascinating, I think, and it's just been really cool to be a part of it.
Yeah, this is a super exciting study. Like you said, just our first couple of weeks kind of trialing this type of data collection, but a collaboration between the Center for Whale Research and Orca Behavior Institute, pairing the center's drone observations of southern resident behavior with acoustic observations or, listening into the whales vocalizing. So we've deployed a hydrophone array from the Center for Whale Research research vessel that hopefully will allow us to localize which killer whales are vocalizing and be able to determine, which vocalizations are coming from the group that the drone is flying over and which vocalizations are coming from other groups. And if there's any sort of reaction behaviorally, or if there are certain vocalizations that are associated with key behaviors like sharing a fish or nursing a calf or those sorts of things. And our initial study question relates to, parsing out some of these potential correlations between certain vocalizations and certain behaviors could greatly increase the amount of information we're getting from passive acoustic monitoring. So we have a good sense of how the southern residents behave in different areas throughout the Salish Sea. But when they're on the outer coast, for instance, where we don't see them, but we may hear them, can we use acoustics to determine if some of these key, survival behaviors are occurring in a given area? But really, I think that's just the tip of the iceberg in terms of the type of questions you can ask with this sort of data. And it's super exciting to have the first attempts at this where, the description of what we're trying to do sounds pretty simple, but in reality, getting everything to align to actually get the data is a little more complicated than that.
Yeah. It sounds really simple. It's like, okay, you fly a drone, you put hydrophones in the water. But so just to paint the picture of what we have 4 hydrophones, each being deployed on poles so that they get some separation from the boat. They have to have weights on them to keep them steady. They have to be in the same position and at the same depth each deployment. They all have to be recording onto a single recorder that is also synced to a voice track where someone, it was usually Sara, was recording where whales were at different times as kind of a backup. We also have a GPS on the boat, so that tells us where the array is. Doesn't tell us which way the array is facing. We have to have an IMU system basically that has a magnetometer and accelerometers to monitor which way the boat is facing. All of that, then we need the whales to actually talk. We need the drone over the whales consistently so it can get a GPS fix roughly on where the whales are. And then we need to do some matrix algebra with everything to actually calculate or estimate the bearing of each signal arriving at the array. And we do that based on time differences of arrival, right? So if you have 4 things, this is not a visual medium. You imagine you got 4 hydrophones, sound is coming from a particular direction. With the speed of sound, it's going to arrive at each of those hydrophones at slightly different times. And from those time differences, you can roughly estimate, actually sometimes pretty accurately estimate the angle of arrival of that call. So the idea is all of those things are synced and going together. We know which way the boat's facing. We know where the boat is. We know where the 4 hydrophones are. And we know where the drone is. And then we know the angle of arrival of each call. And we can kind of see which of those calls are arriving from the group we're actually flying over. I'd say it worked. I'd say we had like half of our days where we kind of had everything up and running, maybe a little less than half of our days. And the other half, we kind of had to work out an alternative thing. So we didn't always have the IMU working, which is why we had the voice notes of somebody saying the drone is over whales at 2:00 from the boat. But we did get it up and running, and we did collect a bunch of data.
And if that wasn't complicated enough, there are other environmental factors that came into play a lot as well.
Yeah, you need all these different data streams working. Michael quickly glossed over the fact they all need to be synced, so you know how they all align to one another, and you need to be able to kind of reconstruct that so they're all matched up with one another. But then, yeah, you need the whales to vocalize when all the equipment is working. And that was a surprise that I have to say I didn't expect to encounter to the degree that we did, where in Harrow Strait, at least, southern residents are quiet about 25 to 30% of the time when they're passing like the lime kiln hydrophone. So we know sometimes they're not vocalizing, but man, when we got started down in Puget Sound, we went quite a stretch dropping the hydrophones and just hearing absolute silence from the whales.
Yeah. And like we'd do like 8 sets, hear nothing, and then it'll be the last set of the day, and we're like, we want to go home. It's an hour ride to get home. We're tired. We have like 2 batteries left.
The wind's picking up.
Picking up. And you're like, oh, let's drop one hydrophone over the side just to see, like, before we go. It's like, oh, now they're vocalizing. Okay, get everything reset. Let's go. And it really wasn't until like the very last day where we had a full day where whales were consistently vocalizing. Throughout the rest of the time, we would usually give, like an hour or 2 during it where they'd be vocalizing consistently. We'd have other times where we'd hear 1 or 2 calls, but it was really that last day where we had good conditions, whales kind of in the configurations we want them, and they were consistently vocalizing.
Everything really came together that day. It was a beautiful day. We had J and K pods making their way north up Admiralty Inlet. That's when we had that unique social group Sara mentioned of the mix of J's and K's, and we spent a good time with them kind of resetting and flying the drone over them and dropping the hydrophone because they were vocalizing. It takes some time to kind of get all these data streams together. After we have the data, we then have to code both the acoustic data and the drone behavioral data. So we're a ways away from actually, doing any sort of analysis. But it was a really positive note to end the field season where it was just like everything worked. It also helped the whales were leaving. It made it easier for us to leave the very next day.
Yeah. I it would have been a nice day to go home too, because the bomb cyclone kind of started getting going the next day, and Dave and I took the boat back up. We survived. I still can't feel either of my pinkies, but we did make it.
Are you going to be doing some of this up in this area as well?
We hope to. Like, it's tough during the summer because both OB and the CWR kind of have other projects that we also need to be doing. It's not the kind of thing that you can do alongside photo ID, really. But we do hope to, if we get some consistent southern resident presence and have some nice days where we're not too worried about photo ID, it'd be great to, get some more stuff to play. And we have another field season planned for next November down in Puget Sound.
Nice. That sounds fascinating.
Yeah, it's pretty exciting stuff. It's something new. It's a new way of looking at, this question of what do these calls mean that we hear them make all the time. And it's really an idea that Michael and I had, over 10 years ago when we were just dreaming of becoming whale researchers ourselves and saying, wow, wouldn't this be cool if somebody could do, fly a drone over the whales and listen to a hydrophone at the same time. And it's awesome that it's come full circle, and now we're actually starting that project.
Yeah, now we just got to start. You've coded our first kind of big set of hydrophone. Our first recording has been coded by Monika, so now I need to run that through the code to see if we can actually get some bearing estimates on all of those calls, and then also pull in the drone data and the boat data and see if we can match everything up and make sure we have everything working before we go whole hog and code everything else.
There was one really cool moment in the field, which is maybe a glimpse of the type of things we might see from this data. It was sort of the first afternoon in my mind where it felt like everything was kind of working. The whales were vocalizing, and we were kind of stopped for quite a while in the same location as whales were sort of doing their thing all around us. And vocalizations weren't super frequent, so I would kind of call out when I heard something over the hydrophones in real time, just to let folks know we were getting some type of acoustic data. And I said loud vocal. And right after that, Michael noticed on the drone that the whales he was over kind of stopped and turned and changed direction. And we don't know yet if that was in, response to that call or something, but it was one of those moments where, okay, this is the type of data we might get where we see a behavioral response to a specific vocalization.
Yeah. And it was really cool from my perspective flying the drone too, because it's the kind of thing you see on the drone quite a bit is suddenly you'll see all the whales, look one direction or suddenly change, and it seems really synchronous. And up until this point, it's just like, how are they doing that? And there was just this moment where I saw them do that. And basically at the same moment I heard Monika say loud call. I'm like, oh wow, it's cool. There's stuff happening.
It might be an acoustic cue.
There might be something happening. Yeah. Another moment like that for me was on that last day. Was it on the last day? Yeah, earlier in the day when we were flying over J27. That was the same day
when he was in the fish pursuit?
Yeah, and he was chasing a chum at the surface, which was great because it's the first time we've seen him doing that on the drone. It's the first time we've seen either of the two big J-pod males do that at the surface on the drone.
We know they feed themselves, to be clear. It's just the first time you've observed it.
Well, and they're probably doing a lot of it at depth where we can't really see it on the drone. And he was chasing this fish. He didn't catch it at the surface. He and the fish both dove out of sight of the drone. And as I'm hovering there waiting for them to come back up, Monika's like, buzzes. Like he started buzzing the fish. And it's like, it started getting my mind going on all of the things we can do with this data. So right now in our data set without the hydrophone stuff, that chase kind of goes in as a unknown. Like we don't know what happened to that fish. We know he was chasing it. They both dove for more than a minute. So he fully could have missed the fish or he could have caught it and eaten it before coming back up. But by looking at those buzzes, we might even be able, if we're really lucky, probably not on that one, but on some other one, we might even be able to hear crunches when they actually catch the fish. We're going to be able to start piecing a lot of stuff together that we wouldn't get from either one of these data sets together. So yeah, I'm really excited to start analyzing it and see what we can find. I think, first priority is do this project. We got, I'm really grateful. We got funding from the Rose Foundation through the Orca Fund, which was funded, going back to fish farms by, is it Cook Aquaculture?
Yeah, the net pen that collapsed off Cypress Island, years ago.
Yeah. They were required to give a bunch of money to killer whale conservation, which gets dispersed through the Rose Fund, and was won by Wild Fish Conservancy. So that's what's funding this is like this cool legal victory, following a really kind of horrific environmental disaster, but now is going towards funding this good killer whale research. So first priority obviously is like, can we just correlate behavior with acoustics? But then there's all this other stuff like vocalization rates related to where they actually are. I think that finding in and of itself that they seem to vocalize less in Puget Sound is really important. Looking at prey pursuit, looking at how they adjust their vocalizations depending on who they're spending time with, like that multi-pod group of J's and K's. Do they sound like a mixture of J's and K's, or do they kind of sound like something else when they're in a group like that?
Call and answer between different whales or different groups is something I'm really keen to look at as well. Is it just the same whales vocalizing, or are they playing off one another acoustically?
Yeah, there's so much. And if we keep collecting it, the analysis of that data can go far beyond what we have funding to actually like do right now. We have plans. We have plans and machinations for the future.
I love it. This is fascinating stuff. I can just sit here and listen to you two talk about it.
You can tell we are got a lot of excitement about it. We just coming off the first field season is always, exciting to get out there and actually collect the data. But like Michael said, it can go in so many directions, and we like to sit around and think about what those directions could be and where we go next. And I think it's cool stuff.
Well, and it's all new. Like you wouldn't have been able to do this 10 or 15 years ago. with the technology that's available now with drones and with the hydrophones, like you couldn't have done this before, but now it's opening up all these new questions and new doors. It's really fascinating.
Yeah. Yeah. And I think as we collect more data, it'll be interesting to see how we can apply different kind of analytical frameworks to it. But yeah, first port of call, just get some basic linear models up and running. Can we predict the rates of some calls from the behavioral states of the whales or vice versa? Yeah. I'm excited. I'm not excited to do all that coding.
Matrix algebra?
Well, the matrix algebra is done. That's coded. I'm not doing it anymore. But doing the marking of individuals in drone frames and all the video coding. I mean, it's fun to watch drone video. It's not necessarily fun to watch the same drone video 20 times to
frame by frame.
Yeah.
I was wondering if you could comment too, just on what you saw from the drone in Puget Sound with things like water quality compared to up here in the San Juans.
Oh yeah. I mean, it was so different depending on where we were in Puget Sound. So like Admiralty Inlet was beautiful. Even like the possession triangle was not terrible, but it was pretty murky. Where it was really rough is, up Saratoga Passage and up that way. It's just mud. Like the whales would come up and they'd bring some water from deeper down up with them and make like this hole in the silt basically. So it was really easy. It was not easy to see whales in that area. But it was easy to track them with the drone because you could just look and scan and see where a whale was just a second ago. Way easier than whale wake or footprints, because it's just like this brown mud and just a whale shaped blue hole in the middle. It was really fun. I mean, it's rough, for behavioral stuff, because the second they're down, they are basically gone. So we know where those whales are. We can still identify them and figure out where they were in space, but it's going to be a little bit harder to piece apart subsurface behavior from that. But it's really interesting. There is no way they can see each other properly in there if they're more than a body length apart. I'm guessing they have to either just kind of have a feel for where each other are or be using acoustics to actually coordinate.
Well, certainly they must have had a feel at times, because there were times in those conditions they were completely silent, which raises its own questions, right?
Well, they were dead silent because they knew we had hydrophones in the water.
There is that.
Yeah, it was bizarre. And I think, just to be clear, I think that water quality there is mostly because of the outflow of probably the Skagit River is mostly what's contributing to it there. I don't think it's necessarily like a pollution thing.
Right.
It's
right. Off the mouth of the Fraser River, you see something similar with all the sediment outflow.
Yeah.
Well, thank you guys so much for joining us. It really is fascinating to hear about this first kind of foray into this study, and we'll look forward to hearing more about it as it goes on. But yeah, thanks so much.
Thanks for having us.
Yeah.
Yeah. Thank you guys. Always fun to have you on and hear your stories. And reach out to us if you have any questions or feedback about this episode or have interest in other topics. You can get in touch with us at afterthebreachpodcast@gmail.com. Share the podcast with friends and other people you think might be interested. And absolutely, positively, no matter what else you do,
stay safe out there. Thanks so much for listening to this episode of After the Breach podcast. If you've enjoyed it and want to help us out, please share this with your friends, family, and any other whale-loving folks you can think of. We would also love to hear your feedback, so please leave us a review wherever you listen to podcasts. If you have topics you're interested in and would like to hear on the show, please send us an email. We'd love to hear your thoughts. You can find us on Instagram as @AfterTheBreach and on Facebook as After the Breach Podcast. And if you'd like to go whale watching with us, then come on up to San Juan Island, Washington State. We run tours with Maya's Legacy Whale Watching, departing just steps away from the ferry landing in beautiful downtown Friday Harbor. It's a great destination for a day trip or multiple days and offers some of the best whale and wildlife viewing in the world. We would love to take you out on the water to see the amazing whales we talk about on our podcast. You can book a tour through the company website at www.sjiwhalewatch.com. And make sure to mention you're a podcast listener when you book. Thanks again for listening, and remember, stay safe out there.